Hello everyone. This lab we're going to talking about open delta transformer. So we're talking about when we have a three-phase transformer, if we have a three single one, if one of them broke down, we still can connect the transformer in an open delta way to supply the three-phase load. So here's the connection. I only use two of those transformers. I connect a primary side in parallel delta. The secondary side also parallel delta, but instead of three transformers, only have two here. So transformer 1 connect between line A and the line B. Second transformer connect between line B and the line C. It's the same for the primary side and the secondary side. I have a balanced three-phase delta connected load on the secondary side. So the load this time we change to 30 ohm for each phase. Now let's look at the calculation. Primary side, line voltage 240 volt. Delta, so phase voltage still 240 volt. Secondary side, transformer ratio 2:1. Secondary side phase voltage 240 divided by 2 give me 120 volt. It's also equal to the secondary line voltage. For the load, it's delta connected load, so the phase voltage on there equal to the secondary transformer phase voltage and the line voltage, 120 volt. Phase current is 120 volt divided by 30 ohm, give me 4 amps. For the load, it's delta load, so the load line current will be √3 higher than the load phase current. I calculate 6.93 amps. For total kVA of the load, 3 times E phase times I phase, it's 1440 VA down here. So for secondary transformer, the line current is going to be the total kVA divided by √3 divided by E line. Calculate 6.93 amps. And I have an open delta connection, so line C and the line A only supplied by one of the transformer, so the phase volt current for those transformers gonna equal to the line current down here. And you also can see the line current on the secondary transformer side equal to the line current from the load. The primary line current, I use the total kVA divided by √3, E line 3.47 amps. It's also open delta. Those line current is only going to be drawn by one of the transformer phase. So the transformer on the primary side, the phase current going to equal to the line current. Now let's look at if we have a maximum kVA for the transformer bank. If we have a total 3 transformer in there, then we know to calculate the maximum kVA of the load will be 3 times each transformer's kVA. I will have 4.5 kVA of the load could be supplied by 3 transformers down here. But when I only have an open delta transformer bank, because the line current going to be supplied by one of the transformer's coil. The transformer coil current equal to the phase current equal to the line current. So for each individual single-phase transformer, the coil current going to be equal to the kVA divided by the coil voltage. I have a 1.5 kVA for each transformer. The coil voltage is 120 volts. Give me 12.5 amps. This coil current will be the phase current, will also be the line current because of the open delta connection. One of the line is supplied by only the phase of this transformer coil. So the total kVA, √3, E line, I line, √3, 120 volt, 12.5 amps. I got 2.598 kVA. This 2.598 kVA is equal to √3 times 1.5 kVA. So in open delta, the maximum load kVA will be √3 higher than one of the transformer rating. Now let's look at if we connect this transformer wrong, what's going to happen? We'll have an open delta connection. I summarize the whole thing for you. So for three-phase transformer, I gave you the phasor diagram. I gave you the sample is if each phase is 120 volt on the secondary side. Then the black letter writing below each phasor diagram is the line voltage going to be supplied by each connection. When I have an open delta connection, if I connect them right, I will have a 3 equal voltage, 120 volt, 120 volt. It's equal to the phase voltage because it's delta. If I connect them wrong, if I flip one of the phasors, now you can see my 3 line voltage is going to be 120 volt, 120 volt, and the 208 volts. Because instead of the 60 degree between these two phasors, now these two phasors go 120 degree. It becomes kind of like a Y connection down here. So this line here will be √3 higher than each of those lines. For Y connection, if I connect them right, each phasor is 120 volt, then 3 line voltage will be 208, 208, 208. We mentioned this before. And if I connect one of the transformer coil wrong, instead of this phase voltage go here, the phase voltage flip, I will have 120, 120, and 208. So 2 of the line voltage drop to equal to the phase voltage. Then for the delta, we only do the delta closure test, because if you connect it wrong, you hook them up, you're going to blow up your transformer. So delta closure test, if you connect 3-phase transformer right, the closure test is going to be raised 0 volts. If we connect them wrong, they're going to raise double the line voltage. For each transformer, if 120 volt, you're going to raise 240 volts. So here is the 3-phasor diagram for right connection of the transformer and the wrong connection of the transformer. I hope you can remember this. Now let's go to the open delta transformer bench to take a look at the reading.